All right, so today we're going to be talking about how to do problems that are similar to number 5 and 6 on your 3.3 homework. So numbers 5 and 6 ask you to find the slope of a line that's parallel to, I believe, line GW. It's a line that's in that picture there on the graph. And then number 6 asks you to find a line that is perpendicular to another line on that graph. So we're going to talk briefly about how to go about doing that. So when you're trying to find, so let's just look at number 5 first. So we're trying to find the slope of a line that is parallel to line TW. Okay, so we know a line that is parallel to TW is going to have the same slope as TW. However, we need to figure out what the slope of TW is first in order to be able to answer that question. So in this example, to find the slope of line TW, you can do it one of two ways. Personally, I know slope is always m, and slope equals the rise over the run. So me personally, I like to go, starting at this first point, I go, okay, my run is going to be 1, and my rise is going to be -2. I can count it. I can say, okay, then my slope is going to be -2 over 1. Some people don't like doing it that way. Some people prefer the formula, which the formula is, of course, slope equals y2 minus y1 over x2 minus x1. And so for this one, we would need our 2 points, which point T is 0, -1, and then point W, you know what, let's, it's whatever. Well, let's try it. Let's see if I can change the color of this in one foul swoop. Oh, I totally can. That's awesome. All right, so let's change the color of that. Okay, maybe I cannot. If I move it over here, can I? Why did it let me do it with that, but not that? Oh well. Whatever. We'll erase that. Sorry, this is a little tangent that you guys probably didn't care to go on. But anyway, T is 0, -1, and W is 1, comma, -3. So I am going to label these as x1, y1, x2, y2, and then I'm just going to go ahead and come over here and plug these into the formula. So my slope is going to equal my y2, which is -3, minus my y1, which is -1, and then my x2 is 1 minus 0. So now if I simplify this out, I end up with -2 over 1, or just generally slope equals -2. So now that I know the slope of line TW, so I know the slope of the line from the graph, it would be GW on your homework. So I know the slope of that line now. That means if I'm trying to find the slope of a line parallel to this line, it's going to be the same slope. Since they're parallel, they're going to have the exact same slope. So for number 5, all I would say is m equals -2, because they're going to have the same slope, as we've said. Parallel lines always have the same exact slope. So that would be number 5. Now number 6 is a little bit different because we're trying to find the slope of a line that is perpendicular to a different line in the graph. So in this case, our slope for a perpendicular line, what we do to find that is we have to, 1, flip it, and 2, switch the sign. So switch the positive and negative. So in this case, our original slope would be m equals negative 2 over 1. Now if we flip it, we're going to get, oh, I kind of ran out of room there. But anyway, we're going to get, it's going to bother me if I leave it. All right, so our original slope was negative 2 over 1. When we flip it, we're going to get negative 1 over 2. So that's flip. And then we have one more step. We got to switch the sign from positive to negative. So it already was negative, so now it's going to be positive. And so our new slope for that line that's perpendicular would be m equals 1/2. And so, long story short, to find the slope of a perpendicular line, you flip it and then you switch the sign. And then for a slope of a line that is parallel, we have to just use the same exact slope because the parallel lines have the same slope. And now, I do want to show you guys one thing real quick and why this works for the perpendicular lines. My guess is some of you won't care and will turn off this video, but that's fine. I'm willing to take that risk because I think it's kind of cool, so I'm going to share it. So anyway, so the slope of our line TW, which I'm going to highlight in blue here, so the slope of that line is negative 2. So it goes down 2 and to the right 1. Now the slope of our perpendicular line, it has to be flipped and then made negative. And so why that is if we just flipped the slope, that means our negative 2 would become negative 1/2. And so negative 1/2 would look like this. If we started here, it would go down 1 over 2, down 1 over 2. So our perpendicular line would look like that. But it's not, that line isn't perpendicular, so that doesn't work. So what we're doing by making it positive is essentially making, from it pointing down, it's going to point up, which it needs to point the opposite direction in order for it to be perpendicular. So by making it positive 1/2, we go up 1, right 2, up 1, right 2, so on and so forth, which leaves us with this beautiful line. That was actually one of my better lines I've drawn, that is at a 90-degree angle. And we can see that it forms a 90-degree angle, and pretty close to a 90-degree angle, even with my poor drawing. So that's why we have to flip it and switch the sign, because if we just flip it, then it's still kind of running the same direction. It just doesn't quite work for us. That being said, I hope